Greetings and welcome to Make Programming Fun Again. My name is Karol Moroz, and in today's video I'm going to talk about column level data encryption. This is video number 9 in my Bitcoin series. You can watch the previous videos on my YouTube channel called Make Programming Fun Again. If you are new to this project, you can also download the source code for the project at github.com/moroz/kidonomichi. And there is also going to be a link to this project in the description below. Now, the reason we need column level data encryption is because in the checkout process, we're going to take some data from the customer and we're going to store some information on the orders that is going to be sensitive or that is going to be secret, because we want to hide it from potential malicious actors. And there is already a library called Go SQL Crypter that is pretty much does what we need, with the caveat that the provider that they use here, called AES-GCM provider, AES-GCM is a good cipher. It's a good AEAD construct, AEAD being authenticated encryption with additional data, AEAD, yes. Except that there is a recommendation to never encrypt more than 2 to the power of 32, or about 4 billion values with the same key, because otherwise it's going to expose it's going to allow the attacker to more specifically, it is described in this issue, and as per recommendations of NIST, NIST being a US government entity, and you should not encrypt more than 2 to the power of 32 plain text using the same key when using a random initialization vector, which basically means if you use random IVs or random initialization vectors, you should not keep using the same key. And that means if you use more than 2 to the power of 32 or about 4 billion, if you encrypt more than 4 billion plain text using this provider, you will have to rotate the key. And one way this can be remedied, one remedy for this problem is using a different cipher called XChacha20 poly1305. And XChacha20 poly1305 has a variant where the initialization vector is 24 bytes long, which means that the IV collision risk is much lower, to the extent that basically you can assume it's almost impossible. So I'm going to in today's video we're going to write something similar to this Go SQL Crypter library from scratch. We could have just written a provider, but I want to show you how all of this works. And this also means we're going to learn how to write custom types for database SQL and database SQL driver. And these are, by that I mean the database SQL library, which has the database SQL package in the Go standard library has an interface called scanner, and scanner is an interface that the type must implement in order for database SQL to be able to scan a value like this. And then there is another type called it's called driver valuer. And this interface is what you need to implement in order for database SQL to be able to serialize your custom type into SQL values. So we could use this to do something similar to you could use this interface to do something similar to what we did in one of the previous videos, where we stored timestamps in SQLite as millisecond timestamps. And I'm going to use this to store encrypted data as slices, as byte slices in the database. And we are going to also fetch this encrypted data from slices like this. And the data we are going to store encrypted in the application, in this Kinenomichi application, is going to include, I think we're going to encrypt emails, and we're going to encrypt key derivation paths for Bitcoin addresses, so that even if you got hold of the private key for the Bitcoin wallet, you wouldn't be able to derive addresses, or you wouldn't be able to find these addresses easily without the derivation path. And that's going to make it so that even if you manage to steal some of the data, you wouldn't be able to steal the Bitcoin. At least that's the idea. And I'm going to open the text editor, and do we have something in here? Okay, the tree is not clean because I was playing around. I'm going to discard the changes by creating a new commit, a new clear commit, and in here, I'm going to start writing maybe in lib. I'm going to create a new package called encrypt, and we're going to need two interfaces, or two types, and it's going to be very similar to what this library does, because I think it kind of makes sense. We're going to implement a type called encrypted bytes, and this is the type that's going to actually get inserted into the database, and that's going to be a wrapper for a byte slice. And then there is this type is going to be, we're going to be able to convert it into a string or into a byte size, and in memory we're going to just store the plain text in a way that can be read inside the application, but the valuer implementation is going to mean that the valuer implementation will encrypt it as will convert it to the encrypted version. And the interface used by this Go SQL crypto library is using readers and writers, but I think since we are not going to be as flexible in terms of the ways data can be encrypted, we can just use what was it? We can just use byte slices. Okay, I'm going to define this encrypted bytes type. But you know what? We can actually start with the underlying encryptor type. So the encryption part is going to be a bit more involved, and here their cryptor interface, I think it's a terrible name, but the cryptor interface is just going to have to allow you to encrypt and decrypt something, and I'm going to use a much more verbose, but I think more easy to pronounce name called Encryption provider.go, and package encrypt type encryption provider interface, and then the my interface is going to be encrypt and value, which is going to be a byte slice, and it's going to return a byte slice and an error, and then the same for decrypt, and that should be enough. And then I'm going to implement a concrete type called xchacha20 provider.go, and package encrypt type xchacha20 provider struct, and it's going to hold a key, which is going to be a byte slice. And I'm going to use this neat trick from this encrypted bytes part, which is going to ensure during compile time that my provider actually implements these interfaces. So I want to implement this encryption provider interface, and the only thing I have to do is just pass this xchacha provider type to in here, and it's going to tell me that I cannot use xchacha20 provider as encryption provider value in variable declaration. We are missing the method called decrypt. And we could write some tests. xchacha20 provider test.go, package encrypt test, and then we can write some. I'm going to write two tests at least. I'm going to write a test for test init chat x. I'm going to call it test init provider, and in here we are going to test the constructor. And then I'm going to write another test called test encrypt decrypt. Although someone has once told me that in the Go world this name would be considered extremely verbose, but you know, Go has no line length limit, so I don't think there is any reason to restrict yourself in terms of long and verbose variable names. And in init provider we we can write three tests: trun is valid with valid key length. And what we mean by that is we are going to generate keys with the proper key length, and we are going to make sure that the constructor will fail, is invalid with too short key. This is not proper English, but it's pretty common in test names to omit articles. Is invalid with too long key. And a valid length is going to be so the valid length is going to equal key equals make byte slice, and that the valid key length is going to be defined in the package chacha20, and we may have to go and get this package. So go get -u this, and then we can import this package in here, and then chacha20 key size. So the key size constant defined in this chacha20 package is 32, and we are going to generate a random key of this length, and then we're going to define a constructor. So func new x chacha20 provider with a key which is a byte size, and it's going to return either an xchacha20 provider, a pointer to an xchacha20 provider, and an error. And then we can ensure that if length of a key is not equal to, or you know what, we are not going to implement this yet. We're just going to implement the happy path, and then we handle the other path later. So I'm just going to return it like this. And now we probably won't be able to do it yet, so we're not going to be able to compile it yet because we don't implement the interface properly. So I'm going to comment it out for now, so that we don't get compilation errors. Okay, and we can run this test. And then actual error equals and encrypt new chacha20 provider with the key, and then we are going to be using testify assert to assert that there is no error, and then we assert not nil actual. So we assert there is no error, and we assert that the value returned from this constructor is going to be not nil. And I wonder, is there... Okay, there is no standard error for invalid key length. I wonder if there is something for in like AEAD package that would AEAD. Okay, so cipher.aad. I wonder if there is some error that we could use. Okay, it doesn't seem so. So I'm going to define my own error types. So error key length equals errors dot new invalid key length, and we can then use it to check that the error types returned from the constructor are going to match are going to be instances of this error. And okay, in here we are going to generate a nonce that is one byte shorter, and we assert error is the actual error is going to be encrypt error key length, and then we assert that the provider returned is nil. And now this test is going to fail because we have not implemented the actual check yet. So before we do it, I'm going to do a similar thing, just with a key that is too long. So it's going to be key size +1, and both of these tests are currently failing. So in the encryption provider, ChaCha20 provider, I'm going to perform the check. So if the length of a key provided is not equal to ChaCha20 key size, then we return nil and fmt error f we wrap the error and we describe that we want this size and we got this size, and that's going to be ChaCha20 key size, and that's the actual key size. So now what do we get? Oh, we didn't pass the error. Okay, so we pass error key length like so. So now the tests are passing because the errors returned from the constructor actually match the expected key error type. And I think this is a good moment to commit stub encryption provider type, maybe implement. I'm going to put more changes into this commit. And then we're going to implement this actual encryption provider part. And these are going to be methods on the xChaCha provider. So I'm going to implement this like so. xChaCha provider encrypt value is going to be a byte slice, and it's going to return a byte slice and an error. And we're going to implement an AAD, but we're going to be able to generate a nonce or an IV. And I'm just going to do it verbose in here. We make a byte slice, which is of the length nonce size x. We generate random bytes, and then if error is not nil, we return nil and error. So we generate a nonce. Oh, and we are going to want to make this nonce the size of the length of the plain text plus cha-cha-20 all you know what, I think we have to initialize the AEAD first. So error equals, how did I do it? AAD error, okay. So cha-cha-20 new x with the key. Oh wait, what? Oh, because we are importing cha-cha-20 and not cha-cha-20 poly 1305. That's a different package. So go get -u this. cha-cha-20 is just an encryption cipher, and cha-cha-20 poly 1305 is an AEAD, and we actually want this AEAD. So yes, cha-cha-20. Yeah, we're going to use this package and not the cha-cha-20 one. And I know that we are cha-cha-20 poly 1305. I know that I'm not including this poly 1305 in the provider name, but cha-cha-20 is mostly used with poly 1305. So cha-cha-20 poly 1305, and the same here, and then same here. The overhead is okay. So the length of the ciphertext altogether is going to equal the length of the plain text plus the length of the authentication tag plus the length of the nonce. We're going to store the nonce in plain text, and cha-cha-20 poly 1305 nonce size x, like this. So what this means is we're going to, at the end of this method, we're going to have everything in 1 byte slice, and it's going to be the nonce first, then it's going to be the ciphertext, and then it's going to be the authentication tag. And this way we're going to be able to ensure that the data is stored securely and that it has not been modified. So, okay, like so. We generated an IV or a nonce, and then we can initialize an AEAD, cha-cha-20 poly 1305 new x with the key. If error is not nil, we return nil and error, and then what do we do with this AEAD then? So how do I use it? Okay, we encrypt the message. Okay, I'm going to call result equals AEAD seal, and the invocation is like this: nonce nonce, and the plain text and nil. So what this means is we the fourth argument is the additional data part of the AEAD. The first part is going to be the target, the destination slice where all of this data is going to be written to. Then the nonce is the initialization vector, and then the plaintext is the message we want to encrypt. And since we pass data like this, the plain text, the ciphertext, and the authentication tag are going to be appended to the same byte slice that contain the original initialization vector. So at the end, we are only allocating a byte slice on the heap ones, and we're using it for everything else. And we can return result nil if it worked. So this is going to return the value as an encrypted data, and then we can go back to the test and see if it works. So we can generate a key in here, and we require there is no error in here, and we require not nil the actual. And since we're not testing the constructor, I'm going to rename this variable to provider, and then let's see, my message is going to be a byte slice with the words hello dear YouTube fans. Yeah, this is a deliberate misspelling. And we have a key, we have a message, and we don't need to generate a nonce because it's going to be generated by the provider. So provider error equals ciphertext equals provider encrypt the message, assert no error the error, and then assert length. Yeah, we want to assert the length of this ciphertext is going to be we want to assert that the length is going to equal length of the message plus 24 bytes of the initialization vector, and then 16 bytes of the authentication tag. And the test is passing because that's exactly what's happening. And then we want to, I'm going to open this in the debugger. Not that we have any bugs at this point, but I wanted to show you what the value actually looks like in the test. Okay, so print message. We can see that this message is a byte size, and then if I print the ciphertext, you can see it's much longer. It's exactly 40 bytes longer than the plain text. and that it looks like more or less random bytes, and it's going to be pretty difficult to make out any of these it's going to be very hard to guess the plain text from this text. And then as you can see, we start with 225, 113, 44, 218. This part is the nonce. It's 24 bytes long. And I'm going to rerun this test to show you that the value is going to change the second time we run it. So these are completely different. This is a completely different nonce and a completely different ciphertext. And of course, it's also going to be a completely different authentication tag. So we can confirm that that this encryption part is working, and then we haven't really implemented the decrypt part, but I'm going to start by writing the test. So decrypted error equals provider decrypt ciphertext, and we assert there is no error, and we assert that the decrypted ciphertext equals the message. So now we can see that it won't even compile because decrypt has not been implemented yet. So I'm going to implement this method. So function decrypt value I'm going to call it ciphertext for now. It returns a byte and an error. So I'm going to need a new error type because we are going to have to define we're going to have to verify the length of the message. So errors new equals malformed message is too short. Okay, and we're going to check if the length of the ciphertext is less than cha-cha 20 non-size x plus cha-cha 20 overhead, then we return nil and error malformed message, like so. Otherwise, for now we're just going to return the ciphertext and no error, and this way it's going to still fail because we are expecting to get the plain text. So I'm going to start by initializing an AEAD error equals cha-cha poly, like this, p key, and I wonder, is the initialization okay? I wonder if the initialization part of this AEAD is slow, then we could cache the AEAD on the provider, and that may be a way to go. Going forward, if error is not nil, we return nil and error. And then we can return AEAD open, and wait, we first need to extract the nonce. We need to extract the nonce from the ciphertext. So this is going to be ciphertext and sliced to the point of cha-cha 20 poly 1305 non-size X, and then ciphertext cha-cha. Yep. So this is going to slice. Oh wait, no. So like this, I think. And but how does this open work? Okay. Can return AEAD open and then pass nil, nonce, message, and nil, like this. So this AEAD open is a method implemented by all AEADs that is basically takes the nonce and the ciphertext, and it returns no error if we have correctly decrypted and authenticated the ciphertext, and it's going to error out otherwise. So let me see if, okay, the tests are not passing. So this means that this encryption provider works, and this also means that we can now uncomment this, right? Okay, I'm going to move this to a different state, like statement group, so that they don't get formatted in such an ugly way. Like this. And okay, yes, this seems to work. And I will store, so status. Okay, I'm going to commit, and then I'm going to modify this provider by storing the AEAD on the provider struct. So it's going to be cipher.aead, and we're not going to store the key itself. So yeah, okay, this is going to be much more convoluted. So instead of checking it in this way, I'm going to check that the provider is implemented on the using this return signature instead. So AEAD error equals cha-cha new x like this, and we store using the key. If error is not nil, we return nil and error, and then we return the provider with the AEAD like so. So then this is going to fail, but this also means that we don't need to initialize this in every method. So let's see. Okay, this still works. And would it still work if we did not make the checking here? So we can actually we could actually just ignore the this part where it checks if the error is where it checks the error, but yeah, I think I'll keep my error message like this. I don't think it changes a lot. Okay. We're testing encryption and decryption. We should also test the unhappy path of not being able to decrypt, but I think that's a bit outside of the scope. And in the meantime, I'm going to start implementing this encrypted bytes type. Package encrypt, and this encrypted bytes is going to be an alias for a byte slice, and we're going to write a constructor new encrypted bytes. What was the interface in here? Yeah, so it actually works with strings. I think I'm going to make it even better. I'm going to call it new encrypted string, and this is going to return an encrypted bytes, and then I'm going to call this one with a byte slice, and this is just going to return new encrypted bytes like this. And in here okay, why can it work like this? Okay. If the length of bytes equals 0, we return nil. Can we do it? I think we can. Otherwise, we return let's see, we return encrypted bytes B. I think so. Okay, it was written, and we are not getting any complaints. Okay, well, I'm going to try and write a test. So package encrypt func test encrypt init encrypted bytes testing .t and let's see, actual equals encrypt. Okay, and this is going to be encrypt test, not just encrypt. Encrypt new encrypted string. I'm going to start with the encrypted string and assert equal t. Are we going? Okay. From I'm going to go from string and from bytes equals encrypt new encrypted bytes, and that I'm going to pass the same byte slice and assert equal t from bytes from string. Let's see. Okay, this seems to work. Of course, this doesn't do any encryption. So the encryption is going to actually happen in the valuer interface. So we can now say encrypted driver valuer equals encrypted bytes, like so. Why can't I do it like this? Oh, they can. So value func, does it have to be on an, okay, this has to be on a value receiver value, and it has to return a driver value and an error. And okay, and we're going to need a global variable because there is no way to pass any context to this there is no way to pass this context to any of this. So I'm in the encryption provider. I'm going to set a global provider in here. That's going to be an encryption provider, like so. And then I'm going to define a function called set encryption set provider, and it's going to take a new provider which is of type encryption provider, and it just says a global provider equals provider. So this way we can call it from outside of this package, and we can set this variable, and we can say if we can start with if length of e equals 0, then we return an empty byte slice and nil. You know what, there is no point doing this, we can just return nil and nil because that's equal to an empty byte slice. And then in this provider we will also provide provider. In here we will also provide this. Okay. If global provider is nil, return nil, errors new, global encryption provider is not set. Yeah, okay. And then return global provider encrypt E, like so. Looks legit. And then value implements driver valuer interface. So now what do we get? Can you get this? Okay. And then let's see. I'm going to actually in this provider. Okay, well, I'm going to generate a key. Var key equals make byte slice with the size of cha20 key size, rand read key, require no error in here, and then provider error equals encrypt new cha20 provider with this key, require no error, and then encrypt set provider like so. And then let's see, so I'm going to rename this test serialize, deserialize. By ciphertext error equals from string value, assert no error in here, and assert not equal t okay, I'm just going to a plain text is going to be this string, and I'm going to pass it in here, plain text, and then plain text in here. and I want to ensure that the ciphertext is not equal to the plain text. And okay, good. And I also want to make sure that there is actually an error if we do not initialize the provider first. So, okay, so we are getting an error. So in here I'm going to define a new error message. So var error provider not set equals errors new with this message. And like this. And then encrypted bytes test, we can ensure that error is, and error is error provider not set. Okay, and then, but we still can ensure that the plain text is not equal to that. And then we try again, and then we shouldn't get any error. So no error, like this. Okay, great. So now we can implement the scanner type. So we want to ensure that it implements SQL scanner, and now we're going to get a message saying that we don't implement the method scan. Func it's a pointer to encrypted bytes scan, and source any, and it should return an error. And first we check bytes error equals source as a byte slice, and it's not an error, that's an okay. So if not okay, which means if the source is not a byte size, we return errors new failed to read bytes slice. And then if there is no provider, we return nil error provider, return error provider not set, and then we return decrypted error equals global provider decrypt the source, the binary. If error is not nil, we return the error. Otherwise, we assign the decrypted value to itself. Do we have to clone it? Probably not really, but because is there like a copy? Oh yes. So we can copy the decrypted string to the destination, right? Why does it complain? Okay, yes, good. Return nil. So let's see. Let's say we are in okay, destination equals encrypted bytes, like so, and then error equals destination scan from ciphertext, assert no error, and then assert equals byte plaintext destination. Line 37. So what is the actual value? Okay, destination. Okay, so there was no error. So what happened? Like this. There was no error, so wait, okay, scan. How about this? Decrypted. Okay, so now we are getting we are correctly scanning this. So now, okay, the tests are passing, and we can now use this. We can now use this value in a sample test, and I know this video is getting kind of long, but I'm going to create a new table, and we're going to modify it later, but I'm just going to create orders. So we will know that in orders we can create, we will store a UID, primary key, email encrypted, it is a byte array, not null, and inserted at timestamp with a second precision, not null, default, now at time zone etc, and updated at is the same, and then drop table orders, like so. So we'll be storing much more data on the orders, but for now let's just do it like this. Goose up, and then in squeal cards, okay, and I'm going to create a new one called orders squeal, and then name insert order, and that's going to, I'm going to just make it an exec. So insert into orders and ID email encrypted, values 1 and 2, So SQL C generate. At this point, we'll just it's just going to treat it as a byte slice. So we need to override the configuration. Yep. Override the configuration. So a table.colon instead. Okay. So in here, we are not overriding DB type. We are overriding colon. Orders email encrypted. It's going to be Go type, and we import github.com/moros/kinu-no-michi/lib encrypt. Type is encrypted bytes. SQL C generate. So now this should be an encrypted bytes, and we can try and see if we start an order service go order service test.go. Okay, so card service is here, order service is here, package services, type order service like this, and then function new. Yeah, I'm just going to search and replace cart with order, and then on this service I'm going to define a method called create order, and that's for now. I'm just going to take the email and I'm going to return, I'm going to return the whole order actually. Order squeal, and that's going to be a 1 and not a not an exec, returning everything. SQL C generate, okay. And it's going to return a queries order, okay, and an error. So actually this is just going to be a return as queries new SDP insert order, and that's also, we're also going to have to take a context and ID. Okay, we're going to have to generate a UID as well. So how did we do it in create in cart service? Okay, like so. So this is going to be an ID, and then email encrypted is going to be new encrypted string email. Okay. Yeah, I think. Wait, what does this insert order return? It returns an order and an error, so this should work right now. And then in order service test, I'm going to copy a lot of card service tests. So package services test, find test create order, T and testing T, and we create the table and we truncate orders instead. and then we need to generate a key. Wait, are we using card service test? Okay, yes. We're going to need a key. So I'm just going to hardcode one in the source code, open SSL rand base 6432, remove the new line, and then copy it to the clipboard. And then var key error equals base 64 standard encoding decode string this, and then provider error equals encrypt new ChaCha20 provider with a key require no error, the error, and then encrypt set provider with this provider. So then let's say order error equals, okay, and then I initialize a service. So service equals services new order service with the database connection, and then order error equals service create order with context background and the user at example.com, and assert no error, assert not nil order. Okay, make test. So now creates new card with nil card ID. I think this may be a flaky test. In card service. Okay, I'm going to investigate it later. But is this test passing? Okay, it is. So that means that if we open the Kino Namichi test now, we're going to be able to see a table orders, but it contains an encrypted email. And I'm going to call it a video. If you enjoyed it a lot, you can consider joining my Discord waiting list at discord.morons.dev. And if you did not enjoy it so much, you can at least consider liking and subscribing. And I will see you in the next video.